Okay, here's a review of the homework problems number 123 through 128. Alright, so 123, this is a really key problem, something very much like you will find on your test. So given the sine or cosine or something of an angle and the quadrant that it's in, can you find all of the trig functions values? So given that sine is positive 2/3, I'm going to draw a little helping triangle for that. Seeing this statement right here, I know that the quadrant is quadrant 2. So my triangle would be oriented like this. And since sine is defined as opposite over hypotenuse, I've got a 2 here and a 3 here. Using Pythagorean theorem, I'm going to find the missing side. So let's see, 2 squared plus x squared. So square root of 5, and it's negative in that quadrant. So now that I've got my triangle, I can find all of the other trig functions. So I've already got sine, 2/3, and cosine, tangent, and the reciprocals of each of those. Okay, so the reciprocal here be 3/2 for cosine. It's adjacent over hypotenuse, so negative square root of 5 over 3. The reciprocal of that would be negative 3 over root 5. Rationalized 3 root 5 over 5. Tangent is opposite over adjacent, so 2 over negative root 5. The reciprocal of that would be negative root 5 over 2. I just need to rationalize this, so negative 2 root 5 over 5. It's really useful to look at the unit circle. We're looking for the angle, actually 2 angles where sine would be negative 1/2. So sine is, we're looking for where is y equal to negative 1/2. So on here, negative 1/2 would be down here, so that lines up with these 2 places. Those are the 2 quadrants where sine is negative. So those 2 spots would be 7 pi over 6 and 11 pi over 6. So make sure you've got that unit circle really memorized for this upcoming test. All right, let's look at the next one. So we're looking for cosine. So where x is positive square root of 2 over 2. Okay, so I know those are fourths. Anytime I have square root of 2 over 2, they're fourths. So where are the fourths that cosine is positive? Cosine is positive here. All students take calculus, and here. So it's this fourth and this fourth. So pi over 4. And 1, 2, 3, 4, 5, 6, 7. 7 pi over 4. Alright, the next one, where is tangent equal to the square root of 3? So my favorite way to look at this is that the square root of 3 probably came from square root of 3 over 2 divided by 1/2, because that simplifies to the square root of 3 over 2. So I'm looking for where is y, square root of 3 over 2, and where is x, 1/2. And also these are positive, so which quadrants is tangent positive? So we're looking at this quadrant and this quadrant. And where is y, the square root of 3 over 2? That would be here and here. So those 2 places. So those 2 spots would be angles pi over 3 and 4 pi over 3 for the reciprocal, so that would be sine and 1 over root 2, so we're going to need to rationalize that. So we get square root of 2 over 2. So I'm looking for where sine, or y value, is positive square root of 2 over 2. So sine is positive here and here. All students take calculus. So those would be the fourths. So this fourth and this fourth. So that gives me pi over 4 and 3 pi over 4. Alright, simplify the following expression. So on this one we've got, I'm going to change everything in terms of sine and cosine. So I've got sine A times sine A over cosine. That's multiplied together. So now I need a common denominator, so I'm going to be multiplying this by cosine over cosine. So I've got cosine squared plus sine squared over cosine. This all equals 1 according to our Pythagorean identity. And the reciprocal of cosine happens to be secant. And 125 part B. First off, I see that I've got sine squared and cosine squared, and so I'm going to take those two and add them together and make that 1, because we know, according to the Pythagorean identity, sine squared plus cosine squared is 1. Next, I'm going to, I already wrote out the critical and useful Pythagorean identities over here, so I'm going to take tangent out and replace it with secant squared theta minus 1. Alright, and then I'm going to keep my minus cotangent square root of theta, and then my minus secant square root of theta. I'm going to replace cosecant squared with what we have here. Cosecant is equal to 1 plus cotangent square root of theta. So when I look at simplifying all of this, I've got, 1 minus 1 makes 0. Secant squared minus secant squared makes 0. And cotangent squared negative with a positive cotangent squared. And the only thing that's left is 1. So all of this simplifies to 1. If I prove, show, or whatever, that all means the same thing. To show that this is true, I would like to work with sine and cosine. So I'm going to start by switching to everything in terms of sine and cosine. So secant squared would be the same as cosine squared. Cosecant squared would be the same as sine squared. And then same here, 1 over cosine squared multiplied by 1 over sine squared. So I've got adding and multiplying. So to add this side, I need a common denominator. So I'm going to multiply this side by cosine squared over cosine squared, and this side by sine squared over sine squared. So this gives me the common denominator of sine times cosine squared. And I've got, on the numerator, sine squared x plus cosine squared x. All of this equals 1 times 1, and the denominator, I'd like it to match the other, so I know that cosine squared times sine squared is the same as sine times cosine. So sine squared x times cosine squared x. So now my denominators match. Oh, good news here. Also, sine squared x plus cosine squared x is equal to 1, according to that Pythagorean identity. So we have made the two sides match each other and verified that this is true. This problem asks to write the equation in terms of sine and in terms of cosine. So if I'm doing cosine with the smallest possible shift, I'm sort of looking at it from here to here. So that's a negative cosine. So I know my amplitude's negative, and the total goes from -1 to 3, so my amplitude is 2. Cosine, it looks like the period is a usual one, so my b value is 1. So we've got x, and then a horizontal shift of, this would be, there's 1 pi over, so of pi over 4, so minus pi over 4. And it's all shifted up by 1 unit. So in terms of sine, I'm looking for the smallest shift possible for a sine curve. It would be a sine curve if I begin here and here, and again it's negative because we're going down first. So a -2 sine of x, and in this case it's actually plus pi over 4, and then still shifted up 1. And for our final question, find the exact value of each of these. So for this first one, in other words, I am looking for where on the unit circle is 5 pi over 3. So here's 1/3, 2/3, 3/3, 4/3, 5/3. Okay, so right here at that location, I'm looking for sine. So sine is the y value, and the y is negative square root of 3 over 2. Okay, so for b, I'm looking for the cosine, or the x value, of 33 pi over 4. This is one of those crazy ones that goes multiple times around the unit circle before it stops. So 33 pi over 4, so we've got one full revolution would be 8 pi over 4, and then another time around gets us to 16. And then if I want 2 more groups around, then that would be 32 pi, and we're right here. So decided to break this into 32 pi plus 1 more pi, and that leaves me right here at pi over 4. And the x value there would be square root of 2 over 2. Alright, so now we're looking at cotangent of negative pi over 6. So negative pi over 6 would be going the opposite direction. That would be right here. So at that place, my x value is square root of 3 over 2, and the y is -1/2. Cotangent is defined as x over y. So my x value over my y value simplifies to negative square root of 3. And for this final one, secant, pi over 2 is found right here, and my x is 0, y is -1. Secant is the reciprocal of cosine. Cosine is 0, so we're looking for the reciprocal of 0, basically, which was undefined.